Good day everyone. We are here to present to you our Arduino project video presentation. First of all, I would like you to introduce to you our Group 5, with a group name Brocode. Together with my members, Mark Allen Hortilano, Daniel Monteroso, RB Labitad, Maria Risa Mejia, and Nikki Zane Canzon.
Project 15 Infrared Control Light LED Matrix. The given project is an implementation of infrared remote control system using Arduino. It utilizes the remote library to decode signal from the infrared IR remote and display number on a 8-segment digital display based on the received signal.
So the materials we will be using are leaf Arduino Uno, prototype shielded breadboard, 5 pieces jumper M2M, 1 remote and 1 resistor 220R, 1 5mm LED, IR receiver diode, and 1 8-segment LED.
Connect the IR receiver. VCC IR receiver connect to the 5V pin on the Arduino. This provides power for the receiver. And GND IR receiver connect to a GND pin on the Arduino. This completes the circuit. Out IR receiver connect to a digital pin on the Arduino, commonly D2. This pin will receive the signals from the IR remote. And connect the LED matrix. VCC matrix connect to the 5V pin on the Arduino for power. And the GND matrix connect to a GND pin on the Arduino for grounding. And the data pins connect the data pins from the LED matrix to specific digital pins on the Arduino.
After that, we will see our group preparing for this project. And for the code start with the hashtag include. We also declare integer rec pin to 11 that defines for the IR receiver. We also declare can create a variable to result of the IR signal decoding. We also declare integer current number that initialize a variable to keep track that stores on IR codes from number 0 to 9 number. The first 10 codes correspond to number 0 to 9. The 11th code is for decrementing the number. The 12th code is for incrementing the number. Number representation array. Int number 108, a 2D array that defines the representation of number 0 to 9 on digital pin 2 to 9, where each inner array represents the state high, low of each pin for that number. Function to display number. Declare void number show. Int I, a function that takes integer I as an input and set digital pin 2 to 9 according to the corresponding binary representation of the number I in the number array. For the setup function, we declare serial begin that initialize a serial communication that bound rate 9600 for debugging. We also declare enable IR that activates the IR receiver to start listening for incoming signal. With the loop function, we also declare if erect decode to check if an IR signal has been received. Check for numbers, a loop iterates over the codes array. If the received signal matches one of the codes for number 0 to 9, the corresponding number is displayed using the number show function. It also updates current number in prints the store. We also declare serial print that prints the received IR value in hexadecimal format to the serial monitor for debugging. And lastly, we declare IR resume that reset the IR receiver to prepare for the next incoming signal. After that, you will see the final output. And for the challenge, our challenge for this Project 15 titled Infrared Control Light with Buzzer. This Arduino sketch illustrates a clear and functional example of utilizing infrared communication to control a digital display and an LED. By receiving signal from an IR remote, the system can effectively display number while also providing a visual indicator of whether the display number is even or odd.
So for this challenge, we will be using DF Arduino Uno, prototype shield with breadboard, 7 pieces jumper M2M, one remote, one resistor 220R, one 5mm LED, IR receiver diode, and one buzzer.
Wiring connections. Wiring connections. The IR receiver data pin connect to digital pin 11 on the Arduino. For the VCC pin, connect to 5B on the Arduino. And the GND pin, connect to GND on the Arduino. And for the LED, the node, connect it to digital pin 13 on the Arduino. And the cathode, connect to one of a 220 resistor and connect the other end of the resistor to GND. And the digital output pins for numbers 0 to 9, connect the following digital pins to an array of LEDs or any other outputs. Digital pin 2 to a control device, digital pin 3 to a control device, digital pin 4 to a control device, digital pin 5 to a control device, digital pin 6 to a control device, digital pin 7 to a control device, digital pin 8 to a control device, digital pin 9 to a control device LED.
And for the code, this Arduino code uses an infrared remote control to display number from 0 to 9. Uh, the display number outputs and control the state. For the start of the code, we declare include. This line include the IR remote library which provide functionality for receiving and decoding IR signal. We declare integer rec pin is equal to 11 that defines the digital pin for the IR receiver. We also declare reg pin that create an instant for IR class to handle IR signal reception. We also declare decode result that store the result of the IR. We also declare integer current number is equal to 0 to initialize the IR current value. We also declare lead pin is equal to array. Long codes. This array stores the IR codes from number 0 to 9 and two additional codes for incrementing and decrementing the display code. 1 to number 6 is for decrementing the number. The 12 code is for incrementing number representation as int number 10 8, a 2D array that defines the binary representation of number 0 to 9 across digital pins 2 to 9. For the function to display number, we declare void number show int I. This function takes an integer input and set a digital pin according to the corresponding binary representation of the number I in the number array. For the setup function, we declare serial begin. We also declare for incoming signal. The for loop config digital pin to 9 as output and set them to highly initially. Pin mode let that config the LED pin as an output. For the loop function, we declare if IR that check if the IR signal has been received. Display number. A loop iterates over the code zero to 9. It calls the number and lastly, we declare IR resume that reset you will see the final output. That's all. Thank you.